Hello, Assalamu alaikum. Can you guys hear me? अच्छा चले ठीक है we'll start where we left off. ठीक है एक सेकंड just अच्छा we're gonna start where we left off. The last time what we did was we did अच्छा we started with naming. ठीक है, the first one that we did is ठीक है मैं I'll share the whole workbook. ठीक है, with marking scheme for P2, P4 and P6 as well. I said this one. Um, we started with alkanes, and I told you there was a system for counting or naming. ठीक है, the starting name was based on number of carbon atoms, meth, eth, prop, bute, pent, and hex, right? So whenever you hear the term bute, that means 4 carbon atoms. Eth means 2 carbon atoms. We did alkanes. Alkanes were what? They were saturated. Saturated meant that they had only single bonds. So they were saturated hydrocarbons, all single bonds. Hydrocarbons means that you just had hydrogen and carbon. So these were alkanes. And they had a general formula as well, which was CnH2n plus 2, right? That was their general formula. So if you want to figure out the number of carbon atoms or the formula or the molecular formula, you can directly figure out using this formula, which is CnH2n plus 2, where n is the number of carbon atoms. So if you have 4 carbons, so H will be 4 times 2 and then plus 2. So that would mean 4 times 2 plus 2. That means 8 plus 2, that's 10. So you can have a look. Okay, this is C4H, H10. Okay, so CnH2n plus 2, right? That is the general formula of what an alkane is. Similarly, we will move on to alkenes now. What are alkenes? Okay, the first thing is that you have CnH2n. That's the general formula. An alkene has it's a hydrocarbon. Again, that means it will have hydrogen and carbon atoms only. But it's an unsaturated hydrocarbon. What the term unsaturated means that it has a double bond. Okay, so that means it has a double bond. A carbon and carbon has to at least one double bond, right? There's at least going to be, I mean, there could be more than one, but normally it's just one. Okay, so at least one carbon and carbon double bond. So that is what an alkene is, and its suffix, its name is going to end with, it will end with "ene." So that's how the name ends. So you never have a 1 carbon atom alkene because you at least need 2 carbon atoms to have a double bond. So there is no 1 carbon atom alkene. So it starts with eth. Okay, eth means 2. So you're going to have 2 carbon atoms. And अच्छा स्क्रीन पे नजर आ रहा है कि मैं लिख रहा हूँ? चलो आगे. So you've got 2 carbon atoms, and you have this one will have 2 H's because carbon needs 4 bonds. This one will also have 2 H's. So that's what ethene is. Then you have propene. Prop means 3. it means 3 carbon atoms. So there's got to be a double bond as well because it's an ene, it's an alkene. So you put a double bond. So it's going to have, this one will have 3 H's, the next one will have 1 H, and this one needs 2 H's. ठीक है, ये clear है? So this is propene. So when it comes to butene, the trouble is you've got so you've got a lot of options when it comes to, just 1 second. So see. So when it's 4 carbon atoms, it's a butene. The trouble is that the double bond has plenty of options. It's got an option to be in the middle, or it's got an option to be at the end as well. Okay, so that leads to different structures. There's a third option as well, where you could put the double bond at the other end, but the first and the third are exactly the same. Okay, these two are exactly the same. It's just a flipped around version. What I mean, if I pick this up and I just rotate it, the double bond is now on the right side. So remember, the first and the third are exactly the same. You clear that the first and third are exactly the same. Is this clear? Ahmed, Hiya, Taha, is this clear?
Yes, sir.
I said so. So you always have to look when you're drawing structures. If you draw it the other way around, uh, remember twisted, flipped around structures, they're not different structures. They're exactly the same structure. And you can now put in the H's. This one has I said this one has so I've added the H's. All carbon atoms, they need to have four H's. This one, or 4 bonds. This one needs 3 more bonds. This one needs 1 bond. This one also needs 1 bond, and the last one needs 3 bonds to complete 4 bonds. I said, so the point is, there's not going to be 1 butene. It's going to be 2 butenes. The double bond could be on the first and the second carbon atom, or it could be between the second and the third carbon atom, right? So butene is going to have 2 different names because you have to differentiate because they're not exactly the same. So this one is called but-1-ene. So before the ene, you add 1, which means that the double bond is on the first one. And this one is going to be called but-2-ene. Okay, that means the double bond is on the second carbon atom. I can number them. This is first. Okay, so is this clear?
Yes.
So you've got but-1-ene and you've got but-2-ene. And as a second year, the other thing is, so that's it. I mean, after butene, they're not going to ask you anything. Okay, that's you just have but up till but. That's what your syllabus is. So just remember butene is going to, propene doesn't have that issue. Because in propene, if you put the double bond over here or you put the double bond over here, that's exactly the same thing. It's just a flipped around version. Okay, I rotate this. What I do is if I pick this up and I just simply rotate it, the double bond is now on the left side. So the double bond being on the left side or the right side, that's exactly the same. ठीक है, ये clear है? तो भी clear है कि नहीं clear है? तो आप, Ahmed, Sia, is this clear?
Clear as.
अच्छा, we're gonna move to the third one, the third homologous series, and that's alcohols. ठीक है, that's the third one. Now with alcohols, what you have is it's basically an alkyl chain. I'm going to explain what an alkyl chain is. An alkyl chain is basically your carbon chain. So it's an alkyl chain plus an OH. This is known as a hydroxy group. It gets known as a hydroxy group. It's not OH minus one, it's just OH. So it's an alkyl chain, which is a carbon chain. Normally, alkyl chains have a formula which is CN, H2N plus 1. ठीक है, अच्छा, we didn't do the, I'm going to do the condensed version of this. This is basically CH2, double bond, and then CH2, right? This is what it's, the first carbon has 3 H's. The second carbon has just 1 H, and then you have a double bond, and then you have a carbon with 2 H's, right? So how do I write this one? It's the first carbon has 2 H's, then you have a double bond, then you have a second carbon which has 1 H, and then you have a carbon with 2 H's, and then you have a carbon with 3 H's. ठीक है, same over here, CH3, CH, CH, CH3. ठीक है, so this one is CH3. ठीक है, double bond CH3. अच्छा, अब ये कि so butanene and butene, right? And there was a general formula as well, which was, what was your general formula? The general formula was CnH2n, which meant that the number of carbons, like if I have 2 carbons, 2n means the H's will be double. So it is C2H4. If I have 3 carbons, the H's will be double, 2n, that's 6. So if you look at C3H6. If you have 4 carbons, CnH2n means the H's would be double, so this would be 8, and that's exactly what this is, C4H8. Okay, now coming to alcohols. Alcohols are basically an alkyl chain, which is a carbon chain. Okay, so whenever you have a carbon chain, and it's a partial carbon chain, which means okay, this is my alkyl chain, and that's my carbon chain, and I have an OH attached to it, right? So this thing over here has a formula which is CnH2n plus 1. This is my alkyl chain, this entire thing. So if I put the number of carbons as 3, so if I put 3 over here, my H's will be 3 times 2 and then plus 1. So it's going to be 7. 3 times 2 is 6. 6 plus 1 is 7. So it's C3 and H7, which is exactly what it is. C3 and if you count the H's, that's 7 H's. ठीक है, is this clear? ये clear है?
Yes.
ठीक है, so the general formula of an alcohol is it's CnH2n plus 1, and then there is an OH that's attached to it. So that's my general formula of any alcohol. So moving on, we're going to try and name some alcohols. I'm going to start with methanol. Now, methanol is meth means one carbon atom. So I've got just one carbon atom, and it's going to have an OH, and the rest will be H's. So this is basically the first carbon has three H's, and then it's got an OH group attached. And similarly, I've got ethanol. That's two carbon atoms. So when you have two carbon atoms, it's going to be CH3, and then it's going to be CH2, and then you will have OH. Okay, so it's CH3, then CH2, and then you have OH. As I remember, always try to draw this one. This is easier to draw. This is directly writing this is harder. If you have this, you can convert this into this. That's kind of easy, but directly writing this, you could get it wrong. So you've got propanol. Now, when it comes to propanol, you have two different propanols because the OH could be placed in many places. You could have an OH over here, and the rest are all H's. This carbon needs two more bonds. And similarly, you've got propan 2-ol as well. So you could place OH in two different places. Actually, you've got three options, but putting the OH on this carbon atom, that kind of means the same thing. Okay, that's basically the same carbon atom. It's just flipped around. I could put the OH on this side, or so it's going to be the same molecule. So between these three carbon atoms, I've got two choices. I can either put the OH on this carbon atom, or I can put the OH on the middle carbon atom. The third one on the left, that's exactly the same. ठीक है, ये clear है? Is this clear?
Yes.
ठीक है. अच्छा, so this one is propan 1-ol because the counting is done from the side that's closer to the group that's attached. So you're going to count from the other side. The OH is on the first one. Over here, it doesn't matter. You count from the left side or the right side. The OH is on the second one. So this one is going to be what? It's going to be propan 2-ol. Is that clear? Clear here?
Yes, sir.
So propanol has two different versions. One is propan 1-ol, the other one is propan 2-ol. And similarly, butanol, that's the one that has four carbon atoms, that will also have different versions. So it also has two different versions. One is that the OH could be on the end, or the other version is the OH could be on the in the middle, right? So the OH could be on the right side, or it could be in the middle. Okay, and these are all the H's. Every carbon atom should be making how many bonds? It should be making 4 bonds. And let me just create some distance between them. So this one is butane 1-ol, and this one is butane 2-ol. One is on the first carbon atom, the other one is on the second carbon atom. And so these are the only two options for butanol. Putting them on this side, that's exactly the same as putting on the right side, right? Or putting the OH on this one carbon atom, that's exactly the same as this one. Okay, is this clear?
Yes, sir.
As finally the last one is, so we can write the condensed formula for these as well. So this one is CH3, and then you have CH2, and then you have another CH2, and then you have OH. This one is CH3. I say it's CH3, then it's CH with an OH, and then it's CH3. So CH3, and in the middle it's CH with an OH. Okay, so it's CH3, then it's CH with an OH. And at the end, there's another CH3. And this one is CH3. And this one would be CH3. Then there is CH2. And then there is CHOH. And at the end, again, there's going to be CH3. Okay, is this clear?
Yes.
Okay, so that's butanol. And so that's butanol. And so you need to know how to draw those structures. And the last one that we're going to do is, the last homologous Cs that we're going to do is, that's carboxylic acids. Now, carboxylic acid is just the structure right now. What they have is an alkyl chain, which is basically CN, H2N plus 1. And that alkyl chain is connected to an acid group, which is C double bond O, OH. So all carboxylic acids have this structure in them. They specifically have this thing. They have a C double bond O, and that C double bond O is attached to an OH group. So all carboxylic acids are going to have this structure. So which is why the general formula of a carboxylic acid is CnH2n plus 1. That's your alkyl chain. Plus a carboxylic acid group. That's the condensed version of this thing. That's CO and OH. So it's CO and OH. CO and then OH. So that's the condensed version of how to write a carboxylic acid. ठीक है? ये clear है? Shanza, is this clear? Taha, Ahmed, here, is this clear?
Yes.
I said that's what a carboxylic acid is going to look like, and this is the general formula. And so if I draw methanoic acid, you remember their name ends with oic acid. So if I draw methanoic acid, Now methylic acid is going to be, it's meth means one carbon atom. So it's just one carbon atom. It's supposed to have a double bond O and an OH. Now, just one carbon atom, that's it. So you need to complete the bonds of that one carbon atom. So therefore, what you would need is you would need one H as well to go along with it, because carbon needs 4 bonds. If I do ethanoic acid, so similarly, eth means, what does eth mean? It means 2 carbon atoms. So eth is going to have 2 carbon atoms, but it will have this double bond O and OH. That will always be there. So you complete the bonds. This carbon has complete bonds. This carbon needs 3 more H's. So this is what it's, if I condense it, the first carbon is CH3, the second one is CO and OH. So that's ethanoic acid. Similarly, you have propylic acid. Now, propylic acid is, I mean, it's 3 carbon atoms. Prop is 3 carbon atoms. Now you're going to have 3 carbon atoms, and then you're going to have a double bond O and OH, and then you're going to try and complete the H's of all the other carbons. They should be making 4 bonds. The condensed version would be CH3, then you have CH2, and then you have C double bond O and OH. And then you have butanoic acid. Now, butanoic acid will be 4 carbon atoms. You should have a double bond O and OH. This one will have 3 H's. This one has 2 H's. This one also has 2 H's. So the formula would be what? It would be CH3, then you will have CH2, and then you will have another CH2, and then you'll have CO and OH. Here, that's butanoic acid. This one doesn't have a version because you can't change the position. This group over here can only fit at the end. That's the only place you can place it. Otherwise, you can't really place this group anywhere. So that's carboxylic acid. That's the last There's one more homologous series which we'll do later on, not right now. And the general formula of a carboxylic acid could also be used, but you just need to be slightly careful when you're using the general formula for carboxylic acid, and that is that N over here is the number of carbon atoms, but one less than that. Like if a molecule has 4 carbon atoms, 1 carbon atom is already in the carboxylic acid group, so there'll be 3 carbon atoms left. So it's the number of carbon atoms, but one less than the number of carbon atoms, because 1 carbon atom is already part of it's already part of your of the carboxylic acid group. So if I want to write this general formula using this formula over here, this molecule has 2 carbon atoms. What I'm going to do is, there's already 1 carbon atom over here, so there's going to be 1 carbon atom over here. So the formula would be, I'm going to take n is equal to 1. 2n plus 1 would be 2 into 1 plus 1, that's 3. And I'm going to have COOH, that's CH3COH. So you have to be careful when using the general formula of this acid, which is that a molecule has 2 carbon atoms. One is already here, so only one is needed. So that will make it 2 carbon atoms. If a molecule has 3 carbon atoms, so one is already here in the carboxylic acid group. In CnH2n plus 1, you would need 2 carbon atoms over here. So it would be C2. H2 times 2 and 4, 4 plus 1 is 5, and then you have COH. So that's how you're going to use the general formula. Okay, so the value of N is going to be 1 less than the number of carbon atoms. Okay, is this clear? You clear?
Yes.
So, okay, one by one, I'm going to share the notes. One by one, we did the homologacies of all of them. And so tomorrow we'll do isomers and we'll start with reactions for each one of these homologacies. Okay? So we'll continue tomorrow then. Okay?
Officer.
Okay. Love is.